Hey, it's Mr. Shrum, and I am back again with one of these mastery test walkthroughs, and we are going to go over momentum today. So in that mastery test, there are momentum problems. And if you look in the lesson, momentum is the product of mass and velocity. And you can write that as P equals mv. P, we have P here that stands in for momentum. We're not really sure why exactly. It may be because there is a Latin variation of the meaning of momentum, like a pushing or a drive, or there's already an M in the equation for mass, so it'd be a little hard to have an M and then another M, and that would just be confusing. So for now, we're just going to pretend that P means momentum. And all you have to do with momentum is multiply an object's mass times the velocity of the object, okay? And another, let's see, group of important equations would be not there, but here in the lesson itself. Here we go. So here we see the relationship between kinetic energy and the mass and velocity of an object. That is equal to 1/2 times the mass of the object times the velocity squared. And we know that momentum equals the mass times velocity of an object. And then you can rearrange this second momentum equation into m equals the momentum divided by velocity. Then you will take the first equation and then substitute this for m in that equation. And if you do that, you get a new relationship between the kinetic energy of an object and the momentum and velocity. So I'll write that on our sheet 2. So that will be kinetic energy, Ke, equals 1/2 PV. All right. So that will be most of what we're using today in this mastery test. So let's get back to my screen. And then we'll get into the actual problems for the mastery test. So on my little teacher sheet, get that out of the way. There we go. Ta-da. Okay. So knowing this information, let's see if we can tackle some of these questions. So we have the first question, and it's asking, the momentum of an object depends on which two quantities, right? Well, if P equals m times v, that means it depends on the mass and the velocity. Right, 1, 2. All right, easy peasy. Next question, an increase in which quantity will result in an increase in momentum. So you're going to be given multiple choices, but if we look at momentum, and we know it depends on these two quantities, if the velocity of an object increases, then momentum increases as well. Right? If V goes up, then P has to go up. And also, if an object is heavier, if it has more mass, its momentum will be increased as well. So velocity goes up. If mass goes up, then momentum goes up, increases as well. Oh, that's a funky looking arrow. You get the picture though. All right, are you following along? Momentum equals mass times velocity, and if mass increases or velocity increases, then the momentum increases as well. Now we're getting into actual numbers. An object has a mass of 35 kilograms and it's moving at 1.2 meters per second. Okay, so we have the mass, m equals 35 kilograms. We have the velocity, v equals 1.2 meters per second. And we are asked for the momentum. P equals m times v. We have m and v. So you just multiply 35 kilograms times 1.2 meters per second. All right, I'll let you calculate that, but not too hard. In the next question, we're asked, what is the momentum of 76 kilograms? So we have a mass of 76 kilograms this time of a horse. So, oh man, should I try to draw a horse? No, I'll just write horse. Running, galloping at a speed of 45 kilometers. So we have V, 45 kilometers per hour. Now, we need this to be in the correct units. The SI unit for momentum would be, if we go back to the lesson, it needs to be in kilograms times meters per second. All right. So that's the SI unit. And if it's not in that, we have to convert, okay? We're looking for kilograms times meters per second. We have kilograms here, but we have kilometers over hour. So we have to convert kilometers to meters and hours to seconds. So let's do that. We have 45 kilometers over 1 hour. We're going to do a bunch of conversions right now. 1 hour is equal to 3,600 seconds, because there are 60 minutes in an hour and there are 60 seconds in each of those hours. So 60 times 60 equals 3,600 seconds. Okay, that's where I got that. And then we need to convert kilometers to meters. For 1 kilometer, there are 1,000 meters. And if you look here, those units cancels there, that unit cancels there, and we're left with 45 times 1,000 is all over 3,600 seconds. That gives us, let me put that in my calculator. And you can do that as well. But we have 45 times 1,000 meters. That'll give us 45,000 divided by 3,600 seconds. And we have 12.5 meters per second. Okay. So that can be tricky sometimes if you have to convert units, but it's not too hard. You just have to figure out what units you need to change. If you're given hours and you need to change them into seconds, for each hour there are 3,600 seconds. If you need to change kilometers to meters, there are 1,000 meters for every kilometer. And then you can set it up in this type of way. I put 45 kilometers over 1 hour, and then I drew this cross section, and then put the conversion there, and then put another conversion, and then you could cross out the units that are diagonal, right? If you have something on top and you have something on the bottom as well, if you have a kilometers here and a kilometers there, you can cross those out, hour, cross those out, and that leaves you with the units you want. And then you multiply it out, and that's what you get. So now we have M, which was 76 kilograms, excuse me. And now we have V after converting, and that's 12.5 meters per second. So you just go about this problem as usual. 76 kilograms times 12.5 meters per second. And that will give you the momentum. All right, there's one last look at that whole problem. Yeah, you're given this. You need to convert the V into the appropriate units, and then you plug it into the momentum equation as usual. All right. Not too bad, just an extra step that time. And then we have the next question. What is the mass of a stone moving at a speed of 15 meters per second and having a momentum of 7.5 kilogram meters divided by seconds? Okay. So we need to know the mass. Oops. Need to know the mass. What do we know already? We know the V equals 15 meters per second. And we know the momentum equals 7.5 kilograms times meter. All right, so this is reverse. We know P and V, and we need to find M. Right? So that takes us back to this equation. Momentum equals mass times velocity. If you get mass alone, you get momentum divided by velocity. So all you need to do is divide 7.5 kilogram meters per second divided by 15 meters per second. And that will give you the answer. And the units will be kilograms. So something kilograms. I'll let you calculate that on your own. But I think you can guess just from the answers you're given. Okay, so that was a reverse one where you're given momentum and you need to find mass. In the next question, you're given statements about momentum and kinetic energy, and you're asked which one best compares the two. So momentum and kinetic energy. What's the relationship between those? And this deals with whether they're vectors or scalars. Momentum, we're dealing with a vector quantity. However, kinetic energy in general, no direction. There's not really a direction when it comes to kinetic energy. Oh, excuse me. Whereas momentum does have a direction in addition to magnitude. So kinetic will actually be a scalar quantity. You don't really say energy in a certain direction. Like this amount of energy, you're just saying an object has this amount of energy at this point in time. No direction, so it is not a vector. Momentum, you're dealing with velocity, so there is a directional quality in addition to magnitude. So momentum, vector, kinetic energy, scalar. Okay. Not too bad. That was more about conceptual. Do you remember these concepts types of questions? The next one is, how does the momentum of a dog and a horse, which are both running at the same velocity, compare? So you have a dog. We're going to say he's a tiny dog. Well, not a tiny dog. Let's say a pit bull. So he's not like the biggest of dogs, but a pretty decent sized dog. And a horse, which is kind of like a dog, but way bigger. What's a horse? Species. Anyway, a horse. There, I did kind of draw a horse. Yes, this is turning into art class. Oh, I forgot the main. It's one of the coolest parts. Anyway, there's a horse and a little doggy. Oh, not my best dog skills. Oh my gosh. How embarrassing. Anyway, there's a dog and a horse, and they're running at the same velocity. Okay? They're both running this way. And V for the dog, and the V for the horse are equal. Okay? They're going the same velocity, same direction, same speed. However, horses are a lot more massive than dogs. M, horse, larger. M, pit bull or dog, smaller. So when it comes to momentum, we have mass times velocity. Well, if V is the same for both, but the horse is more massive, M for horse is larger. If the mass for horse is larger, then the momentum is larger as well. Does that make sense? So they're running at the same velocity, but the horse's larger mass means that it will have a larger momentum as well. So even if things are going at the same speed, that horse has more oomph, more momentum, because the dog is a lot smaller compared to a horse. Hopefully that makes intuitive sense. Like you could already kind of understand that. But now you have some math, science, sciencey terms to back that up. And number 8, from my teacher workbook, which statement best compares momentum and kinetic energy? And it's between these equations, right? So I'll rewrite those here. So we know that momentum equals mass times velocity. However, the kinetic energy equals 1/2 the velocity, or the momentum times the velocity, right? And in these statements, they're giving you, if you double the velocity, what happens in each of these cases. So if you double the velocity of an object, what happens to the momentum? Well, if P equals mv, but you have 2v, then that will double the momentum. or kinetic energy equals 1/2 mass times velocity squared. So there are two ways to look at the kinetic energy one. If you double the velocity, the momentum doubles. Double the velocity, you double the momentum. However, for kinetic energy, I'm going to use this equation. 1/2 mass times if you double the velocity here, you're actually K equals 1/2 m times 4v. So if you rearrange everything, K equals 4 times 1/2 mv squared. So you're actually making the kinetic energy 4 times as large. If you double the velocity, you're making the kinetic energy increases 4 times over. Does that make sense? So from this equation, if you double velocity, you double the momentum. But because velocity is squared here, an increase in velocity will lead to a larger increase of kinetic energy because that value is squared. So if you put in 2 times velocity, that 2 is squared, and 2 times 2 equals 4. So that is why that works out in that way. All right, I'll leave that up for a few more seconds for you to understand that. But V, we just have one V, so if you double it, momentum is doubled. V is squared here, so if you double V, that will increase the kinetic energy 4 times, or quadruple it. That's another way to say that. Does that make sense? And that's all because of these equations. Not so much this one, but this one and this one. Okay, almost done, folks. We're given another statement question. Which statement best compares the momentum of a stationary truck and a car in motion? Well, stationary means velocity is 0. So if V is 0, P equals a mass times 0. That equals 0. So it would have no momentum if velocity equals 0. Excuse me. But if a car is in motion, it will have some velocity. So it will have momentum. Easy enough. So if something's not moving, it does not have momentum. And the last question for the mastery test, test bank questions are, which statement best compares the momentum of a 5-kilogram fish swimming at a speed of 10 meters per second? So that's our first fish. We have another fish. We got a 2-kilogram fish, and he's swimming at 10 meters per second. So much like the questions before, mass times velocity gets you momentum. So if this fish has more mass, more m, more momentum. The one with more mass has more momentum. Okay. Well, that is it for that momentum mastery test. If you have any more questions, ask me them in Canvas. Send me a message and I can help you out with your physical science journey. And hopefully I can help you understand these concepts a little more. But yeah, that's all. And I will see you guys next time. Bye.